Hey guys, and welcome to this lesson all about adding and subtracting rational expressions. Now, adding and subtracting these rational expressions is going to be just like adding and subtracting fractions from before. And we're going to start easier, and we're going to make our way towards more complicated problems as the lesson goes on. So to begin, how do we add fractions or subtract fractions with like denominators? Well, if the denominators are the same, like in 1 over 4 plus 5 over 4, I think we have the luxury of just adding across our numerators. And we end up with 6 over 4. Also known as 3 over 2 when we simplify. Or in 7/6 minus 10/6, since our denominators are the same, we have the luxury of just subtracting across our numerators. And we end up with negative 3/6, or negative 1/2 when we simplify. Exact same idea with rational expressions. So in our first example, one thing I want to point out right away is that we need to talk about our variable restriction. X cannot equal negative 3, because if it were, then we'd have an undefined expression. Okay, now that that's taken care of, our denominators are the same. That's groovy. And so our numerator will just be, let's see, 2x plus 6. But just like we did with our regular fractions before, we need to look and see if there are any simplification opportunities. So I'm going to factor this numerator because it can be factored. There is a common factor of 2, and that numerator becomes 2 times the quantity of x plus 3 over x plus 3, and we see that there is a simplification opportunity, and so the sum in this case is just 2. So no matter what value of x you substitute in here, anything other than negative 3, no matter what, your sum in this case will just be 2, which I think is pretty powerful. Okay, in this next example, we can choose to factor now and find our variable restrictions. I'm just going to go ahead and add now because I know I'm going to factor later. So since our denominators are the same, we have the luxury of adding across our numerators. So we know our denominator would be x squared minus 4x minus 21. And our numerator, when we add these together, I think will just be x squared plus 4x plus 3. But of course, we need to look for simplification opportunities. So let's factor everything real quick. I think that numerator factors as x plus 3 times the quantity of x plus 4. Oops, sorry about that. That's totally supposed to be an x plus 1. So for the rest of this problem, just pretend that's an x plus 1. Thank you. And that denominator factors as x plus 3 times the quantity of x minus 7. Before we simplify, good opportunity to talk about our variable restrictions. I think x cannot be negative 3 or positive 7. Now, I think we can say yes, we can simplify away these x plus 3's, yielding a grand total of x plus 4 over x minus 7. So hopefully you get the hang of this. Let's just have you pause the video and quickly do these two examples on your own. I do want to make a note, especially with these subtraction problems, do be very aware. I might even go ahead and put in some small parentheses. Don't forget that you are subtracting the quantity of 4x plus 19. So you get negative 4x minus 19 when you subtract, or negative x plus 11 when you subtract here. So do be careful. All right, why don't you try these now? All right, I hope those weren't too bad. So now let's move on to a slightly more difficult iteration of this. What happens when we need to add or subtract fractions that don't have the same denominator? In this case, how do we add 2/3 plus 5/6? They don't have the same denominator. So what do? We make them have the same denominator. What we're going to do is we're either going to have to, with one or the other, or both of these fractions, change them into equivalent fractions so that the denominators become the same, and then it's like an easy problem from before. And so what I'm going to do here is I'm going to rewrite this as such. I'm sure you could do this in your head, but I want to show you the strategy that's going to most closely resemble what we're going to do here. I'm going to write this as 2/3 plus 5 over 3 times 2. So we need these denominators to be the same. This denominator is 3. This denominator is 3 times 2. Well, in order to make them look the same, if we multiply this denominator by 2, then we'll have the same denominators and we'll be good to go. Of course, we need to deal with only equivalent fractions here, so we're going to multiply this by 2 over 2, right? 2 over 2 is 1. We're going to end up with 4/6, which is an equivalent fraction to 2/3. And that is going to yield us 4 over 2 times 3, or 4/6 plus 5 over 2 times 3, which is 6. Now that we have the same denominator, now we just get to add across our numerators and life is good. We get 9 over 2 times 3, and you know what? We need to look for a simplification opportunity. 9 is 3 times 3 over 2 times 3. We see that we can simplify away these 3's. We end up with our final sum of 3 halves. Now I know that this was quite a lot of work for a seemingly easy fraction addition problem, but I just really wanted to show you exactly what the strategy is going to look like when we deal with these kind of problems. So let's take a look at our first example right here. What I would suggest doing first is factoring everything. So let's factor x squared minus 9 as x minus 3 times x plus 3. I think we know that our variable restrictions is that x will not be able to be 3 or negative 3. Just want to get that out of the way right away. Okay, so it's clear that these denominators are not the same. So we need to somehow turn this denominator into x minus 3 times x plus 3, and then the denominators will be the same. So what do? We can multiply this by x plus 3 over x plus 3. Right? We have a fraction here in which the numerator is the same as the denominator. This is just 1. This will yield us an equivalent fraction, and then the denominators will be the same, and we will be ready to rock. So we are going to end up with, let's see, 2 times the quantity of x plus 3 over, you know what I sometimes do to kind of save myself a little bit of work? Not a big deal here, but when we have really nasty denominators, it'll help. I kind of say, you know what? Tell the reader, you know what? This is our least common multiple, or least common denominator of these two. And then when I'm rewriting the problem again and again and again, I just write least common denominator, because I have defined it already, so the reader does know what that means in this case. So we've got that over the least common denominator minus 12 over the least common denominator. All right, and we know that, let's see, we're going to 2x plus 6 minus 12. We get 2x minus 6 over that least common denominator. Let's now factor this numerator to see if there's any simplifying opportunities. 2 times the quantity of x minus 3 over. Now, when we're looking for simplifying opportunities, might as well write this out. So now x minus 3 times the quantity of x plus 3. Aha! There is indeed a simplifying opportunity, and we end up with a grand answer of 2 over x plus 3. And so there we go. That's kind of the gist of how we take care of these addition and subtraction problems. I want to show you one kind of odd example here, because I want to make sure you know how to handle those. And then this is just a more difficult example, and then there'll be some for you to try on your own. So I'm looking at these denominators, x minus 2 and 2 minus x, and they are almost the same, but not quite. How can we, make them the same? Well, I hope you remember from a previous lesson, I'm just going to kind of write this off to the side, that x minus 2 is equal to negative 1 times 2 minus x. Or vice versa. 2 minus x is equal to negative 1 times x minus 2. These two denominators are almost equal to each other. If we multiply either of them by negative 1, then they would be the same. So you know what? We're going to multiply this denominator by negative 1 because we like this one more. It's already in standard form. So I'm going to take this second fraction and I'm going to multiply it by negative 1 over negative 1. And what we are left with, is 3x minus 2 plus negative 4. I'm kind of doing two steps at once here. I know the denominators are the same, so I'm just kind of adding across the numerators. Don't forget, this is negative 4 all over x minus 2. And that numerator becomes 3x minus 6. I'm just going to kind of write that very small in here, 3x minus 6. And now when I factor that, we get 3 times x minus 2 over x minus 2. Oh, check it out. That's pretty cool. We end up with a grand answer of just 3. So as long as, forgot my variable restrictions, as long as x does not equal 2, then whenever you substitute in for x, the answer to this addition problem with all these fractions will definitely be 3. So I just wanted to make sure you were aware of that kind of tricky example with these multiplied by negative 1 business. One more example I want us to do together before I have you try some on your own. This is difficult more just because it's a lot of terms, not necessarily conceptually more difficult, but just computationally more difficult. The strategy remains exactly the same. Let's start by factoring this denominator. So we can factor that as x plus 4 times x plus 7. Awesome. So that means that this is going to be our least common denominator here, x plus 4 times x plus 7. How can we make this denominator equal to this denominator? We can multiply this fraction by x plus 7 over x plus 7. So I hope you're getting the gist of this now. And what's going to be tough now is that, we've got 4 steps of multiplication to do there. I'm going to toss in some parentheses just to make that clear. We need to multiply this out and then add 21, and that's going to be our new numerator. And I'll tell you now that when we do all of that, when we do all that multiplication, we end up with, let's see, 2x squared plus 15x plus 28. All over that least common denominator of x plus 4 times x plus 7. Yowza! Now, of course, usually this is the time when we look for a simplification opportunity. But of course, to look for a simplification opportunity, we need to factor this numerator. Does this numerator factor? Yes. Yes, it does. We have to use the AC method of factoring. Like, oh my God, as if this wasn't hard enough. Now we got to remember the AC method, right? 2 times 28 is 56. Are there 2 factors of 56 that add to 15? Yes, there are, 7 and 8. So when you factor this, and I urge you, take a moment right now, pause the video and factor this using the AC method. When you factor this using the AC method, you end up with 2x plus 7 times the quantity of x plus 4. And now all of that is going to be over x plus 7 times x plus 4. We see that, yes, we can indeed simplify away these x plus 4 terms, yielding our final sum as 2x plus 7 over the quantity of x plus 7. So there's every single factoring skill we had before is on the table. And of course, I should have remembered to talk about our domain restrictions or variable restrictions. X cannot equal negative 4. X can also not equal negative 7. So that's about as hard as they come. So I've got 3 more examples here that hit those 3 kind of examples, just like these 3 we did. I want you to try them on your own. So why don't you pause the video, give these 3 a try, and when you're done, play the video, and we'll see how it went. All right, so I hope that went well for you, and we just have one more iteration to make our way through, which is when we have unlike denominators in our fractions, but we need to multiply both fractions by some form of 1 in order to obtain a common denominator. So here's an example with simple fractions that we're going to use to explore this first. So here's how I like to add 3/4 plus 5/6. What I like to do is rewrite this fraction addition problem in which both of those unlike denominators are factored to their prime factorizations. So 3 over 2 times 2 plus 5 over 3 times 2. Now perhaps you remember this skill from a previous math course, but what we need to do is somehow find the least common multiple of 4 and 6 so that we'll have common denominators or like denominators. And perhaps you know the skill to do that already by using prime factorization. I like to use a little intuition as well. We need these two to look exactly like one another. This denominator has a 3 as a factor. This one doesn't, so this one's definitely going to need a 3. So we're going to multiply this guy by 3 over 3. Awesome. This denominator has 2 2's as factor, whilst this one has only 1 2 as a factor. If you want these guys to look the same, this one's going to need another 2. So let's multiply this fraction by 2 over 2. Now what we have is a situation in which this denominator and this denominator are exactly the same. What is this number? This number is 12, and 12 is the least common denominator here. But I'm just showing you the strategy that's going to be more applicable when we're using these rational expressions. So what we'd have in this case is our denominator is 2 times 2 times 3, or 12, and our numerator will be 9 plus 10, which is 19. And that's exactly the strategy we're going to use with these rational expression examples. All right, so I'm going to walk you through 2 examples here, and then after that, I'm going to have you try 2 on your own. So, just like before, our first step is going to be, let's factor these 2 denominators so we have a better idea of what our least common denominator might be. So this first denominator is going to factor as x plus 2 times the quantity of x minus 1. And this denominator is going to factor as x minus 5 times x minus 1. Now, we need these two denominators to look exactly the same. Well, I note that this denominator has an x minus 5 as a factor, whilst the first does not. So we need to multiply this fraction by x minus 5 over x minus 5. And I'm going to go ahead and write this down here as well, meaning that, okay, this is what the denominator of this fraction is going to look like now. I also note that this denominator doesn't have the x plus 2 factor that this denominator does. If we want these denominators to be the same, this guy's going to have x plus 2 as one of its factors. So let's multiply this fraction by x plus 2 over x plus 2. And so now we see that down here, this is what this denominator is going to look like. It now looks like we have the exact same denominator in both of these fractions. We'll be able to add them just like we did before. As a matter of convenience, I like to label this our least common denominator so that we don't have to copy it every single time we do another step. So let's rewrite this fraction now. I think we're going to have 3 times the quantity of x minus 5 plus 4 times the quantity of x plus 2. Now here's where I'm kind of cutting a little corner here, where I am going to just write least common denominator down here. We have explicitly let the reader know that this is our least common denominator. I'm just saving a little time copying it down again and again and again. At the end, we'll bring it back in case there's a simplifying opportunity. All right, so when we expand these two and collect our like terms, I think our numerator is going to be 7x minus 7, all over that least common denominator. And now we see that let's look for a simplifying opportunity. I think we can factor out a common factor of 7 from our numerator, 7 times the quantity of x minus 1. Let's expand that least common denominator, x minus 5, x plus 2 times x minus 1. And we see indeed there is a simplifying opportunity. These x minus 1s will simplify, and our final sum will be just 7 over x minus 5 times the quantity of x plus 2. Everything is groovy, but let's not forget, as I have been recently, to note our variable restrictions. I think that x cannot equal 5, x cannot equal 1, nor can x equal negative 2. And so that's the general strategy for how we're going to add these rational expressions in which these denominators are not the same. So let's use those skills to tackle this next problem right here. Of course, again, the first thing we're going to want to do is to factor both of these denominators. So we got x plus 1 times x minus 1 as our first, and x plus 2 times x minus 1 as our second. Of course, we want these two denominators to be exactly the same. So I think this denominator lacks an x plus 2 factor. So x plus 2 over x plus 2. So this is what our least common denominator is going to look like. This denominator lacks an x plus 1 factor. So let's multiply this fraction by x plus 1 over x plus 1. And so, yes, we have now manufactured our least common denominator. All right, and now we're ready to go ahead and actually subtract these. So, our new fraction, our sum, will have a numerator of 2 times the quantity of x plus 2 minus 3 times the quantity of x plus 1, all over this least common denominator. Real quick, I think that this would be 2x plus 2.
Yeesh, another mistake. Yes, that's definitely supposed to be a 4, but for the interest of the rest of the problem, let's just pretend it's a 2. Sorry, guys. Thanks.
Minus 3x minus 3. So we will end up with, let's see, negative x minus 1 over that least common denominator. If we factor out a negative 1 from that numerator, and we expand our common denominator, x plus 2 times x plus 1 times x minus 1, we see that, yes, there is a simplifying opportunity, and our final difference, the answer to this problem, will be negative 1 over x plus 2 times x minus 1. Again, I didn't put in our variable restrictions earlier. I should have. My apologies. Our variable restrictions are such that x cannot equal negative 2, 1, or negative 1. So I hope you're really getting the hang of this. And so I think this is a great opportunity. Why don't you now take a crack at these next two problems, and when you're done, play the video and we'll see how it went.